So this section right here is section 3, and today we're going to try to learn how to graph using intercepts. So the first section, again, was the first kind of way to, the second section actually, was how to graph using or finding solutions through a table and then plotting the points. Today we're going to use intercepts. Let's start out by just talking about this word right here. What does it mean if you intercept something? You cross it, right? Okay, that's a really great way of saying it. So if you think about when we go back to our coordinate plane, we talk about intercepts, right, on our coordinate plane. What intercepts do we talk about? Or where could we intercept something that would be really specific on that coordinate plane?
On the X and the Y.
On the X and the Y what? Axis, right? So we're going to try to find something that intercepts the X-axis and the Y-axis. And as Drake said, we're going to see where it crosses the X-axis and the Y-axis. So he's exactly right. So we're going to look at where it crosses. So again, the X-axis is what axis? Which way does it go? Left to right, right? So my X-axis is this axis, or on ours over there, it's the green axis. And then my Y-axis goes up and down, or on ours, it's the yellow axis over there. Okay, so again, when you start doing this right here, make sure that you are putting numbers on your graph. Okay? And then basically what we're going to do is, to do this, you're going to try to find points on each axis where it crosses. Where the line, we can say, crosses. So if you think about this right over here, and we come back and we look at our axes over here, see what happens with that blue? It smears all over. Remind me never to use blue again. Okay? So, if we're going to talk about an axis, what is true if I have some number that is on the green line? What has to be true about that point? Any point on this green line has to have what as a part of it? If you think about, pick a point in your, or let's pick a point right here. What is that point?
-6.
What else?
0.
0. Where does 0 go? In the Y. Would you all agree with that? Okay. And so that was this point right here. If I pick this point over here, what's that point over there? 8, 0. And what did both of those have in common?
0.
They had a 0 in it, right? Now, if I pick this point right here, what's that point?
0, 7.
0, 7. And if I come down here and pick this point, what's that point?
0,
And what does those have in common? They both have a 0 too, right? So when you're going to try to use the intercepts, you are going to put 0 into the other variable. So, if I'm going to try to find the x-intercept, that means where it crosses the x-axis. So the x-intercept crosses the x-axis. I'm going to put 0 in for which variable?
Y.
It's always the other variable, so I'm going to put 0 in for y. Then my x is going to be some positive or negative number. If I'm going to find the y-intercept, it's obviously where it crosses the y-axis. So now I'm going to put 0 in for what?
The X.
Right. If I'm finding the y, I'm going to put 0 in for x. And then my answer is going to be positive, or negative some number. So basically, when you do these problems right here, and they then ask you to graph, you're going to have 2 points, one on the x-axis, one on the y-axis, and you're going to connect your dots. Okay, so the key to this, or the kind of special characteristic of this is the only time you graph with only 2 points. And those 2 points are right, have to always be on one of the axes. One on the x and one on the y. Every single time that's going to happen. So you're going to go through the process first of trying to find the x and y, and then you're going to take those and put them on your coordinate plane again. When you put them on your coordinate plane, make sure you use your ruler again to make it straight. X and y axis. Make sure you put numbers on your x and y axis. And then plot your points, and then connect your dots with the ruler again. And what do I need at the end? After I connect those dots, don't forget to put the little arrowheads on it. Because why? It's a line, right? And they go on forever. Okay? So, a lot of people think this is kind of an easier version of what we did yesterday. But it's totally up to you. So, here's my equation. X plus 2y equals 4. So remember what we did yesterday? Making the table and finding the 4 solutions? We could do that again, but we're just doing a different version of it. So today we're going to try to use the intercepts. So when we do this on a quiz or a test, make sure you read the directions to see if they specifically ask you which version to do. If they just say graph the line, you can use any version that you want. Okay? So, the first thing that you got to decide on, which one do you want to find first? The x or the y? The x. So if I'm going to find the x, I'm going to put 0 in for what? Y. So I'm going to put 0 in for y. Now, why do we like 0, Aaron? Why did you pick 0 all the time the other day? Yesterday. It's easy, right? Because when you put it in, what happens? It basically just cancels it out, right? So when I put 0 in for y, I cover that up, and now look what it says. X is equal to 4. Boom, that's my answer. See how easy it is? That's one of my points. Now I'm going to find the y-axis. So now I put 0 in for what? X. And now when I put 0 in for x, I actually have a little bit of work to do, but how do I get y all by itself? Divided by 2, divided by 2. So again, it's not real complicated, and you probably don't even really have to do that, but that's what you're doing. And then my answer is 0, 2. So then we would take that information, and we'd come over here, and we'd plot those 2 points. How do I plot this first point? Where do I go? Right 4, and it's right on the axis, right? Every single point that you do for these problems right here should always be on an axis today. Okay? How do I do the second one? Just up 2. And then we're ready to graph. If they ask us to graph it, we simply come over here and we connect our dots. Okay? So, you got to remember that every single time that you do this and they ask you to graph it, and then you're going to go through and you're going to plot your 2 points, and they should always be on an axis, and then connect your dots. All right? What do you think? Easier than yesterday or about the same? Probably easier, right? Okay, so let's try a couple more. See if you still think they're easier at the end. Let's do this one. 2x plus 3y equals 7. I think it was 7. Nope, 6. Alright, so again, if you want to stay consistent and always find the x first, you do that. If you want to find the y first, sometimes it's totally up to you. It doesn't really matter which one you find first. So go through the process and see if you can find the x-intercept and the y-intercept. The points where they're going to cross. Everybody got it? So which one did you find first, the x or the y? X. So that means anytime that I'm finding the x, I'm going to put 0 in for y. So again, when I put 0 in for y, like Mary did yesterday, cancels that baby out. That's why we like it. We end up with 2x equals 6. So what's x?
3.
3, right? Divide by 2, divide by 2, and we get 3. Then when we go the other way, which means we're going to find our y-intercept, we put 0 in for x. So again, we cancel out, and then we get what? Positive 2. And then we take both of those numbers and graph them. How do I graph this first point? Over 3. And then this one? Up 2. So they're all positive so far, but obviously we can have negative ones too. Okay? Now, let's do this same equation. Here, we'll make this one negative. We're going to say 2x. I'm going to change this to minus 3y. And then I'm going to change this to the 7 that I had up there the first time. The only reason I want to show you this one is, obviously when I do this problem, it's exactly like, the process is exactly the same. I'm still going to do this. I'm still going to put 0 in for each of my variables. But what happens in this one, when I put 0 in for the y, okay, it still covers it up, and I end up with 2x equals 7. Well, what's x really?
13.
Right? X would equal 7 halves, right? Because I would divide by 2 and divide by 2. Well, what's 7 halves? Not 2.5. 3.5. So here, when you write this as your ordered pair, it doesn't bother me to write it as 7 halves. But if you have to graph it and you're thinking ahead, you might want to, instead of writing 7 halves, write it as 3.5. Now again, I know we stressed a lot about not using decimals and so on and so forth, but for some people, looking at it as 3.5 comma 0 is a lot easier to graph than 7 halves. They don't kind of think about that in their melons. And when they have 7 halves up here, then they try to kind of go over and right, and then they get confused. So if you want to use a decimal there, that's totally fine. What happens when we put 0 in for x? Now we get what? Right, so we get negative 3y equals 7, and what's y? Y equals negative 7/3, or what's negative 7/3? How many times is 3 going to 7? 2 and a third, right? Everybody agree with that? So again, you can use either answer, and again, if you're going to graph it, you might want to use negative 2 and 1/3, okay? Now, let's go over here and look at this to actually graph these two things. So if I want to graph these two things, how the heck? Now this first one, probably not that hard if it's 3.5, 0, right? Where am I going to go for 3.5, 0? Right, but which way? To the right. So I go 3, and then, like you said, right in between the two, right? So that one's probably not too bad. How do I graph the second point? 0, comma, negative 2 and 1/3. Up, down, left, or right? Down 2, and then 1/3. So it's got to be not quite half, but right in between that and half. And then I would still take my ruler and connect my dots. So I just wanted to show you that even though that you end up with a fraction in your point, don't freak out about it. It still works out just the same. Okay? Questions there? Not too bad, right? All right. The last thing they talk about in this is what I would call special equations. Have we mentioned special equations before? Maybe not. Okay? So, special equations to me are the things that we're going to talk about right now. And why are they special? Well, what have you noticed about all of these equations that we worked with so far? How many variables are in those equations? And most of the ones we talked about yesterday, they had two variables also, right? An x and a y. Well, special equations, why I consider them special? They only have one equation, or sorry, one variable. So when you talk about these right here, go ahead. You need to put your money up there if you got it.
Interrupting.
When we do these special equations, there's only going to be one variable. All right, so my two special, remember when we drew all of these lines, we were getting equations like that, or graphs like this, where they were kind of slanted lines. Well, when we have special equations, there's only going to be one variable, so we have two different lines. My two different lines are horizontal lines and vertical lines. Okay? What does it mean if you have a horizontal line? Which way does the lines go? Left and right, right? That's a horizontal line. And so obviously a vertical line is what? The other way, up and down, right? We show off our vertical, right, when we jump. Some of us don't get very high. Right? All right, so here's the question. Question of the day. The question of the week, really. So if you think about this, is they can only have one variable. So, for horizontal, do you think horizontal lines have an x or a y?
X.
What do you think? X.
Y. X.
Why do you say y? Because they didn't say why, so you want it to be different. So what if I tell you the different guy's right? Okay? So this is the weird part, and this is the hard part, that a lot of people get messed up with their milling. So we're going to say y equals some number, positive or negative, it doesn't matter, is going to always be, anytime that you see one variable and the variable is a y, you know that it's going to be a horizontal line. So that obviously means that x equals positive or negative some number has to be a vertical line. Every single time. It doesn't matter what the number is. Okay? Now I'm going to prove it to you. You told me that horizontal lines are which way? Left and right, right? So when I'm looking at my coordinate plane, I'm going to try to draw a horizontal line on my coordinate plane. Pick some number. I don't care what it is. 2. Okay? Positive 2 would be where? Up, down, left, or right. If it said, what variable would have to be if it's a horizontal line? Y, right? So where is y equals 2? Up, down, left, or right? Up. So if I went to y equals 2, and I put my finger right there, and then I put my yardstick across right here. Any spot that I touch my yardstick, right over here, what is my value of y?
2.
And if I touched it way over here, what's my value of y?
2.
What's my value of y there?
2.
What's my value of y there?
2.
Right? So every single time that we say y equals 2, that's why we draw it as a horizontal line. Same way with this, right? If I said x equals -9, where would you go for x equals negative 9? Up, down, left, or right? Left, right? So I go over here to negative 9, right? So how else do I get another negative 9? I got to come up here for a negative 9. I got to come down there. So if I draw a vertical line every single time on that yardstick that I touch the yardstick, my x is at negative 9. That makes sense? So yes, even though that the x's go left and right, my graph goes up and down. Even though my y's go up and down, my graph goes left and right. That makes sense? So again, that's one of the concepts that's kind of weird and gets messed up in our heads because you just don't really think about it. And it's kind of, in a sense, backwards to what you think of. But essentially, it's just doing it. So, questions with either intercepts or our special equations? Not too bad, right? So again, anytime that they ask you to graph the equation, you can use the intercepts method if you want, unless they specifically ask you to graph it by a different version. Meaning, how we did the first, or yesterday's version, which was getting 4 solutions, or we're still going to have another version called slope-intercept form, which we will do next week. So here are your problems. If they ask you to graph, make sure that you use graph paper again, please.